In this video, we want to go over some of the techniques that you're going to use to solve these problems on your coordinate geometry worksheet involving circles. Okay, now I'm not necessarily going to um, provide you the answers, but I will provide you some techniques for how we go about solving them. So the first two are very similar. They're saying find the equation of the circumscribed circle around the right triangle with coordinates as indicated here. And then number two is saying the same thing, although it does not specify it's a right triangle. So we're going to the sketch pad to illustrate some things here. Here I have 3 points, okay, and of course through those 3 points I can construct a triangle. Now the circumscribed triangle would be the triangle which is the triangle which contains the 3 vertices of this triangle. Okay, the circumscribed circle would be the circle containing the 3 vertices of this. So we can't construct a circle because we don't know where its center will be. So geometry taught us that if we were to find the perpendicular bisector of 2 sides, okay, so that is to take one side, find its midpoint, and then construct the perpendicular bisector. So again, that would be the line that we just drew has the midpoint of AB, okay, which looks to be -4, 1, and has a slope which is perpendicular to it. Now, if I do that once again, okay, do that now, selecting this segment and constructing it. Let's go full screen here again. Sorry. Okay, and select the segment AC, construct its midpoint, and then construct the perpendicular bisector there. Lo and behold, the point where they meet, where the 2 perpendicular bisectors meet, is in fact the center of the circle. So therefore, I should be able to draw a circle from there, from this point out to A or B or C, and it's one and the same. So there we have it. Okay, so any of these problems where what you're after is the equation of the circumscribed circle around a triangle, then what you need to do is you need to find the perpendicular bisectors, the equations of the perpendicular bisectors of 2 of the 3 sides, and then you need to find their point of intersection, and that point of intersection is the center of the circle. So there's the center of my circle, okay, and of course the radius of the circle would be from drawn from the center to any one of the points. So that would be your radius of the circle. Now, for certain types of triangles, what we'll notice is that there's convenient locations, okay, for where that. This is what's called the circumcenter. This point here, which is the center of the circumscribed circle. So that point D is the circumcenter. Now, when the triangle is a right triangle, so I'm going to make a right triangle out of this. There we go. We got a right triangle here. We got a B at a right angle of B. When the triangle is a right triangle, it's nice because the circumcenter, that is the center of the inscribed the circumcenter, the center of the circumscribed circle, is right there at the midpoint of the hypothesis. So which makes your calculations considerably easier, because all you have to do is find the segment, which segment is the hypotenuse, and then find its midpoint, and that would be the center of the circumscribed circle. If the triangle is obtuse, as we're seeing here, then the circumcenter would be at a point which is outside of the triangle. So the circumcenter, again, is the intersection of the perpendicular bisectors of any two sides, but their intersection in this case is outside of the triangle for an obtuse triangle. Of course, we can see that angle B here is definitely obtuse, and therefore a triangle is obtuse. And again, when it's a right triangle, the circumcenter, the center of the circumscribed circle, is at the midpoint of the hypotenuse, and for any acute triangle, it's going to be somewhere inside of the triangle. So looking at some of your problems now, that certainly discusses how you would approach number 1 and number 2. Number 3 is to find the equation of the line containing the centers of the two circles. Well, here obviously the center is at 5, -7, and here the center is yet to be determined, but you will easily determine that by completing the square. Okay, here, okay, is this is a problem which is for us to determine where these three lines intersect. Well, so you take them in pairs. You say what because the intersection of these three lines is forming a triangle. So obviously you want to find the point of intersection between sets of two. So the first two, find that point of intersection. The second two, find their point of intersection, and then maybe the first and the third. So you combine them, the first and second, find the point of intersection. The second and third, find their point of intersection, and then the first and the third, and find their point of intersection, and they will be the 3 points defining a triangle. Okay. Now, actually, in problem number 10, having those 3 points of a triangle, then it's going to ask you to find, if you say, I think problem number 10, find the center of the circle that circumscribes the triangle resulting from the conclusion of problem 4. So that comes back to this guy and says, okay, yeah, now we have a triangle. Let's find the center of that triangle, and that's done the same way as we showed you over here, by finding the perpendicular bisectors of two sides and their point of intersection. Okay, so let's go back and let's see. Number 5 is to find the equation of a circle which passes through 2, 3, and -1, 1, and has its center on the line. Okay, this is reminiscent of the problem we looked at previously. Let's kind of go back and check that over here and see if we can remind you here. So basically, this is a problem we looked at one of the previous worksheets. So here are 2 points on the circle, and the 2 points A and B on the circle define a chord of the circle. And so the chord of the circle is perpendicularly bisected by a diameter or a radius. Okay, so basically in this problem here, we can refer back. So through these 2 points, there is a chord, and perpendicularly bisecting that chord is a diameter. Okay, and so what you want to do is to find the equation of the perpendicular bisector of these 2 points and find its intersection with this line, and that should be the center of the circle. And from there you can find the equation of the circle, because then you need to find the radius having the center, then the distance between, okay, the distance between the center and any point on the circle, one or the other of these will give you the radius. So there you go. That goes back to this construction. Again, you're effectively finding the equation of the perpendicular bisector of a chord and its intersection with some other line that contains the center. Okay, and that should give you kind of a go-ahead procedure for these, and we'll talk about the back page of those in the next video.